Hi, this is Neeta. I shall be explaining eigenvalue, eigenfunction, eigenstate in this video. It is a very important concept in linear algebra, mathematical physics, quantum physics, and its application in most in engineering discipline and basic sciences also. It may start with something simple, and I shall proceed on the explanation of eigenvalue. Let's first analyze the wave function for that. So, do you know how do you define any particle? We defined any particle by wave function, but why? Because particle has dual nature. You know, the wave are associated with any moving particle. And suppose if we have if we have to determine position, momentum, energy of the particle, how can we determine that? For that, firstly we have to apply wave function which is denoted by psi, Greek letter. Then we have to apply operator on. Do you know what the operator is? So operator is one of the mathematical operation used to measurement on the wave function. Suppose consider wave function psi. On that we apply wave function, suppose a cap. Then we get something like this. Okay, which is equal to lambda into psi. So understood how can we apply operator on the wave function? So for understanding this all, let's now see diagrammatically. Suppose consider any wave function. Suppose this is the wave function, and for the measurement on it we apply the operator. Suppose this is wave function and this one operator we apply on it for the measurement of the wave. Okay, so resultantly we get new wave function with different shape. Let's see, this shape is completely different from the initial considered wave function. So by applying operator, shape of the wave function is completely changed here, and we get a new wave with new shape. It's clear? So wave function operator theoretically भी देख लिया, डायग्रामेटिकली भी देख लिया, अब देखेंगे मैथमेटिकली. Now suppose we consider any wave function ux, and suppose ux is equals to sin x. We considered that, and on that we have to apply the operator. Suppose we apply operator p cap on the wave function u of x, and p cap which is equal to del upon del x. ux क्या है यहाँ? वेव फंक्शन. And on that we have to apply operator p. P is the operator here. Okay, so now apply. by applying wave function, operator. By applying operator on wave function u of x, we get u of x. This wave function apply on that, so which is equals to ऑपरेटर पी कैप क्या है, डेल अपॉन डेल एक्स. ओके, एंड यू ऑफ एक वेव फंक्शन की वैल्यू साइन एक्स, एंड फॉर दैट रिजल्टेंट वी गेट डेल अपॉन डेल एक्स इंटू साइन एक्स कॉस एक्स. तो देखो यहाँ हमने यू ऑफ एक्स वेव फंक्शन कंसिडर किया, उस पर अप्लाई करेंगे ऑपरेटर पी कैप जिसकी वैल्यू हमें मिल रही है कॉस एक्स. सो डू यू नो द ग्राफ ऑफ साइन एक्स? ग्राफ ऑफ साइन एक्स लाइक दिस, समथिंग लाइक दिस. ऐसा रहेगा साइन एक्स का ग्राफ. कुछ इस तरह से रहता है. यहाँ 0 रहेगा पाई 180 डिग्री, then 2 pi. The graph of sin x we consider wave function is something like this, and by operating operator we get cos x, and graph of the cos x something like this. So see here, this is the graph of sin x and cos. So shape of the wave function is completely changed by operating operator here. देखो ये sin x का ग्राफ और cos x जो रिजल्टन हमें मिला by applying operator. क्या है, दोनों की शेप completely चेंज हो गया है sin x का by applying operator. Okay, let's turn on our main topic, eigenvalue and eigenfunction. So to find out position, momentum, energy of the particle, firstly we apply wave function on it, and on the wave function we apply operator. Resultant we get, that resultant we known as eigenvalue, and on and which on operate we called as eigenfunction. And this wave function is a variable quantity that mathematically describe the wave characteristic of particle. And also the wave function for given that physical system contain measurable information about the system, and a solution exists for time independent Schrodinger's equation only for the certain values of energy, and these values are called eigenvalue. And next, eigenstate. So eigenstate is the measured state of object possessing quantifiable characteristic such as position, momentum, etc. So up to we discuss eigenvalue, wave function, operator, eigenfunction, mathematical expression, and hope you got it.